Hello. Now let us talk about two-line electric drawing. This is applicable for DC circuits mostly, where you're required to draw the electronics or the circuit, the connections for the instruments that you're going to use. And a typical example is this figure right here, where they give you the power on the left-hand side. Is going to be a DC source, could be a battery, could be a source. You can put a notation in and tell what kind of source this is. So the important thing is that in general, you need 1.5 volts for this circuit. Later on, if you're doing the schematics for production, you will give a part number and you will specify details about what amperage and what um, power you need. But right here is just a 1.5 volts. Amperage and power is not given. Remember, the power is the voltage times the current. But at this point, it's a generic circuit to give you an example. R1 is a resistor, obviously, and R2 is another resistor. You can have capacitors, diodes, inductors, and this is an example right here where you have the battery, you have a resistor, and you have an inductor. All right, so let's create this example or something from this example. So if you go to your layers, you have to create a few layers. We have the basic layer 0. We have 0 volts, which is our common or return to the battery, which is not the same as ground. You can have another one called ground if you want to ground the circuit. In fact, we can do that. We can say create a new a new layer. I'm sorry. We're going to call it ground, and it's going to be green. Okay, so now we have a layer that is called ground and is green. All right, that's good. So on your layer, you have 0 volts, which is going to be the return. You have 10 volts, which is your hot or your power, the high potential power, 10 volts, or it could be 1.5 in this example. I chose 10 volts for my example. And you have components where we're going to place the resistor, the inductor, the diodes, etc. And we're going to have a ground where we're going to connect to our common to keep our common at 0 volts. What happens if you connect common you're not connecting your common to your ground? That's usually when you need to have a negative voltage, so like negative 10 volts for a motor, for an electric motor. When negative 10 volts will rotate counterclockwise and positive 10 volts will rotate clockwise. But in this case, 0 is a common, so it's understood that ground is going to be our blue line. You'll see how you connect ground if you need to. But if you need to create this circuit, we can start with our common line, which is this over here. So we're going to create a line, and we're going to say 0 start at 0. Your ortho is on, so very simple. We create a line that is 10 units vertically up. Then we're going to go to components, and we're going to create a power source. Could be a battery. So let's create a line. Starting from this point, make sure you have your ortho on, your endpoint. Starting from here, you're going to go say 3 units, enter, and then practice your mirror and create a mirror along the line. You want to get rid of the entities? No. Okay, you can create another line and could be around 1.5 units up. And then this is going to be, let's say 5. Enter, and then we're going to do a mirror. And that's going to be our source. Excellent. All right, so now we have to create our positive or potential. It's going to be 10 or 5 or 1.5 volts. So for that, in this case, we named it 10 volts. If you need 10 volts and 5 volts, you can create another layer. It could be orange, for example. So to keep symmetry, we're going to say that this is another 10 units. All right, and then says that it's going here to the right hand side. Let's say that is 30 units. Let's say that is going another 30 units for inductor, and another 10 units down. All right. Actually, that seems to be a little large, so we'll have to think about that again. Let's do another line that is just 5. 5, enter, and we can copy that line and put it where we had our first termination at 30. Okay, so notice that in this case, this is not important the distance. I'm just keeping track of the numbers so that it's symmetrical. But if you're doing if you're manufacturing this circuit, you indeed have to consider the distance. In fact, you would probably use a different software like Eagle, which AutoCAD makes it, so that you can export your drawing to a PCB, which means printed circuit board. Those are the green and yellow and copper-looking boards where circuits are. Those are PCBs. But in this case, we're just creating a drawing for an electrical two-wire connection. All right, going back to our components, we're gonna create a resistor. So how do you do that? Well, it's many ways, but the simplest way is to do it with a line that goes, say, is 2 units for the first one and 2 units for the second one. Okay. So each line is 2 units. In that case, when we create another line, we go from this point, get rid of your ortho condition, to this point, and 45 or 30 degrees. All right, and then you close it. And then you have a triangle with the same sizes, so isosceles triangle. Then we're gonna do a mirror. And then go back to ortho, so we don't have to worry about being misaligned. And we can actually get rid of those lines. We can do that at the end. Okay, so move this to this point, okay? And if you get rid of that line right now, you'll notice that you'll be able to create a resistor that goes from here to here. All right, the problem is that I actually have a resistor that is way too big. So let me scale it instead of redoing it. If it's hard to have a right distance, all right, maybe like that. You can also type a number. When you say scale, you can say put 0.2, which is going to be 20% smaller. Of course, if you put 2, it's going to be 200% larger. So for instance, if you do scale in this resistor right here, let's do scale. And you select a point, and then here you type 2, then it increases to 100%. All right, but since we don't have dimensions, I just wanted to go ahead and do something that it was going to be symmetrical. Okay, so that might be too small. Might be too small, so let's try putting this here to continue the circuit. All right, I think that's good enough, but you get the concept. So you just copy the component so that you can carry on your resistor. Then let's go back to our common line, which is the blue or return. If you have any fundamentals on circuits, we have this line going back to our return. All right, and at this point, we are gonna connect the ground. So we are ready to connect our ground, which is gonna be a line okay. And then let's create the the ground. So if you remember, it's going to be, let's do a 1, enter, let's repeat our line, which is right click, repeat. Let's put it here, let's put 2, and enter, repeat line, which is again right click to repeat the line, and 3. Okay, so now what we have to do is do a mirror, and we have a ground. Perfect. Let's go back to our components, and let's go ahead and create a the inductor, which in this case is very simple. Remember, an inductor is a coil, and again, depending on how many coils you have, the amperage and the magnetic field will change, but it's actually going to be a semicircle. It's not going to be a circle, a full circle. You can cut it or trim it later with a line, but this is easier. In this case, I actually want the arc to go the opposite way, so I just need to go to my arc up here, make sure I start, end, and radius, and then no, that's not gonna work. Let's do a line first, and let's do a line that is 0.75 units. Enter. Now, when I go to my arc, I can start from here and I'm aligned. Okay, all right, that's good. Let's remove this line and let's copy this multiple times. So let's say 5 times. It's gonna have 5 ampere turns. And I'm gonna have to scale this inductor as well because it's too small. Let's see, how can we do this that looks better? Maybe like that. Okay, good. All right, so that's my inductor. If we want to have the arc be a little larger, all we have to do is choose 2 points. And in that case, oh, I forgot that the arc has to start from the bottom point. So if you start from the bottom point, in this case, you're gonna have a larger arc. Maybe that's gonna be more appropriate. So mirror, no, not mirror, we're gonna copy this part from this point to this point. So choose that same part and keep moving the part to the end point with your ortho and your snap on. The snap that you need is the end point. All right, so let's close the circuit and we're gonna do a line from here. So let's line from this point, use this reference to this point, enter. And that is my circuit. Actually, I think I can get my resistor to be a little larger. But that is just to make it look more symmetrical. All right, more like that. Okay, I like it because it's a little larger than the battery. All right, so back on your common or your zero line, go here to your end point, and you have this circuit right here. So we have a few things to do here. One is to do circles on your component layer, and that is going to be the soldering points. That's going to be the soldering points. Actually, to make sure the same radius, we just copy this guy, select the center. Yep. To select the center, make sure you have the center, geometric center snap selected, and place it on your endpoint. All right, so now we can do the hatch that we learned before. The hatch command is going to ask us to select the areas that we want to fill. In this case, it's going to be all these 4 areas. All right, and at this point, we're ready for our annotations. So let's go to annotations. Oh, before that, there's another thing we can do. So for those of you who are in electrical engineering or have background in circuits, if you're going to use this circuit to capture a signal, you must have a diode. Otherwise, if you remember, let's put an annotation here. Remember that, a single line, the inductance, so L being the inductance, is equal to, V voltage is equal to inductance times di over time. Okay, so this is current and this is capital L. So the voltage as a function of time is equal to the inductance of the coil in henries. This is, remember that the inductance of the inductor is in units of henries, and that is times the change in current divided by time. So you integrate this, and it could be a sine, a cosine, or an exponential. But what this means is that the voltage could change in an instant very high. You could have very high voltage. So if you have a 10-volt voltage here, you can have what they call flyback voltage throughout your components. So you're gonna see a lot of your components have something called diodes to protect the equipment. So in that case, we're going to create a diode. And a diode is another passive element that is very useful. So let's go ahead and do this line right here. For that point, I'm going to randomly choose a point. So line, let's do line from this point here to there. Okay, and then do a mirror. Make sure you go back to your ortho on. All right, cool, that's good. And now repeat U line from here to here. This is, you have a Zener diode or a regular diode. This will be a regular diode. Let's do a hatch on this guy. All right, so now we have the diode completely filled. And we're going to connect a line from here to here. All right, so one thing that we can do is specify the connections a little better. So I just thought about something that we could do. I'm going to put a little solder point here. All right, and let's fill that guy too with solid. Okay, so that could be a different type of solid paste if you want. You're usually gonna have to solder these points. All right, so one is gonna be at the end point. Another one here. Another one here. Another one here. And another one here. Okay, so in that case, we can continue our circuit and connect our diode to our line, which if you didn't connect it to the line is fine because you can always trim it. enter. All right, copy. Okay, all right, and then we're gonna do another line, but we have to change our layers. We have to go to our voltage return, and we're gonna select from this point line. There you go. Enter. And we can also do a trim here. So we trim with this line. All right, so in that case, we are finishing up our circuit. We just have to put the annotations in. And in that case, we can use single line, which could be small. It doesn't have to be too big. So let's do 10 volts. But I want to go back to my 0 component layer. So it's white. All right, so now we're ready for our annotations. Single line. So 10 volts. Okay, now you have two options here. Either you go to your properties and modify, or you select your part or your annotation and select it. And scale it. So we're gonna scale it down a little. That is much better. We move it closer to our source, and we're gonna copy this over here and over here, and then here we can put our positive. If it's not clear by now, it should be because our ground is at the bottom here. And this resistor, we're gonna name it R1. So just double click on the annotation so you can overwrite R1. Let's see, copy here and here, and L1 and 1N. That will tell you that it's a type of diode. Okay, so that is your two-wire diagram. If you want to plot it or export it, you can. Let's move it to somewhere around here. So when you go to your images, or your layout, let's see how that would look. Okay, that's okay. One thing to consider though is that on your layout, you can get rid of the grid. So when you go to your layout, you can check your model, your grid out. There you go. And then when you change from model to paper, like we did in our first class, then you're able to plot or export your part. So a few things to consider. You might want to change the thickness of the wire if you think it would look nicer. Or more than that, what I think it will make it look nicer is if we removed this large solder line here and here and here also, and used the solid line, circle, Select the center, place it in the center, place it on this center here, place it on the center here, and place it on the center here. Okay, you don't need it here because it's a single wire. And now what you do is just simply fill it with solid material, which is going to be basically the paste or the solder for the junctions. All right, and you do the same one on the common or return line or the 0 voltage line. Enter. Okay, in this case, you're ready to print your drawing and send it to your customer. Again, if you're thinking about actually working on circuits, this is just to create the schematics. If you want to create this on a PCB, then you might need to move to Eagle because you will be able to use your editor to create your printed circuit device. Now that I'm talking about Eagle, I realize that there's an issue here. So let's copy this resistor because a diode also needs a resistor. A diode by itself will maybe not work sometimes depending on the size of your application. So we're gonna have to scale this down. Okay. Move to, as long as it's aligned, we're good. Okay, good. So now we select it again and we select ortho and we are going to move this closer to this point. And then we do a line from this point to that somewhere in here. That's perfect. And I would feel a little better if I got my resistor to be a little more, it would be closer to this size. So in that case, we might need to scale it a little bit more. Scale, choose this size. All right, I think that will work. Let's go back to our home tab so that we can create another line and close this circuit right here. Okay, that's good. Perfect. And now we're gonna use one of these circles, which is the solder. We're gonna choose the center and we're gonna place it, removing the ortho condition on, we're gonna place it at the center. All right, so, oh, this line is not straight. Okay, so what we're gonna do is select that, and no, it's not. It's because I don't have my ortho on. Line, selecting this point. All right, perfect. So let's trim it. I want to make sure that it's passing through the center there. Okay, perfect. Let's just go ahead and create another comment here that this is going to be R2. All right, now you can evaluate the circuit and check it, see if you do need the resistor or not.